As we've seen with equivalent fractions, there are multiple ways to write a fraction that represents the same amount. So what's the best way to write a fraction? We say the best way to write a fraction is its reduced simplified form. And the way we can reduce a fraction is we can simply divide by a number. So for example, if I had the fraction 30 over 42, we can divide the top and bottom numbers, the numerator and the denominator, by the same thing to get an equivalent fraction. Notice 30 and 42 can both be divided by 6. When I divide by 6, we end up with 5 over 7. And that is a reduced equivalent fraction that is the most effective, efficient way to represent that value. Now, we divided by 6. But we didn't have to actually divide by 6. With 30 over 42, we had some choices. We might have noticed those are both even. And if I notice they're both even, I might have divided by 2 instead. And when I divide by 2, you'll get 15 over 21. Make sure when you're reducing your fraction, though, you double check to see, can we reduce any more? And 15 and 21 are both divisible by 3. So if I divide them both by 3, we end up with 5/7, which is the same answer we had before. Now, sometimes this division method's not the most efficient method. Another option to reduce fractions is to use that prime factorization that we saw in a previous video. With prime factorizations, we can reduce out common factors, and we can subtract exponents. Let's look at what this looks like for our example, the 30 over 42. We're going to find the prime factorization of 30 and 42. 30 is divisible by 2, 15 times. 15 is divisible by 3, 5 times. And so the prime factorization of 30 is 2 times 3 times 5. Over the prime factorization of 42, 42 is divisible by 2, 21 times, which is divisible by 3, 7 times. All of those are prime, so 42 is 2 times 3 times 7. What's nice about the prime factorization is we can reduce out those common factors, and what's left, in this case 5/7, is our reduced fraction. Let's try one that's a little more involved. Let's try 140 over 350. Let's find the prime factorization of 140. 140 is divisible by 2, 70 times, which is divisible by 2, 35 times, which is divisible by 5, 7 times. So circling my primes along the way, 140 is equal to 2 squared times 5 times 7. Over, let's find the prime factorization of 350. 350 is divisible by 2, 175 times, which ends in 5, so it's divisible by 5, 35 times, which is divisible by 5, 7 times. So 350 is 2 times 5 squared times 7. Now, when we reduce here, notice on the 2's, we've got a 2 squared over a 2. If I divide out 1, 2 from the bottom, I divide out 1, 2 from the top, subtracting the exponents. So there is still a 2 left over on top. Similarly, with the 5's, I divide out 1, 5 from the top and 1, 5 from the bottom. I'm left with 1, 5 on the bottom, and then the 7's divide out. So what's left is a single 2 on top and a single 5 on the bottom. This fraction is equivalent to 2/5. Let's try one more. Let's try 30 over 315. Well, the prime factorization of 30, it's divisible by 2 15 times, divisible by 3 5 times. So 30 is 2 times 3 times 5. Over 315, if I add the digits, I see that they add up to 9, which is divisible by 3. So it must be divisible by 3. Goes in there 105 times. Add the digits, it's still divisible by 3. Goes in there 35 times. ends in a 5, so it's divisible by 5 7 times. So the denominator, 315, is 3 squared times 5 times 7. Reducing out, 1 3 from the top and 1 3 from the bottom leaves a 3 behind. 5 reduces out with the 5, and then I'm just left with a 2 on top and a 3 times 7 on the bottom. We can multiply those together to get 21, and 2 over 21 is our solution.